Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin our 92nd CoCoRaHS Weather Talk webinar. A very warm welcome to you joining us today. I'm your host, Henry Regis. Running the technical side of our program is our colleague, Noah Newman. We're coming to you live from the Colorado Climate Center in Fort Collins, Colorado. A big thanks to our donors out there. Your gifts are used to sponsor our Weather Talk webinars, among many other CoCoRaHS endeavors. Well, for today's webinar, we have the pleasure of having with us Alicia Wasula. She's a certified consulting meteorologist and president of STM Weather, located just outside of Albany, New York. During the next hour, Alicia will talk about the use of weather experts in litigation, looking at the long history of the field of forensic meteorology and how observational data is used to understand meteorologic conditions. She will also give examples that demonstrate how forensic meteorologists help attorneys understand weather as it relates to a specific case. Alicia received her bachelor's, master's, and PhD in atmospheric science from the University at Albany. Her primary focus is on providing scientifically sound, clearly communicated weather information for her clients. Alicia likes to read, hike, play the violin, and garden. She grew up a New York Mets fan and still roots for them today. Let's give a big CoCoRaHS welcome to Alicia. Hi, Alicia. It's great to have you with us today.
Hi, thank you so much for having me.
So as we start off today's program, I'll ask you a question that I pose to all of our guests, and that is, how did you become interested in weather? Was there a single event? And then secondly, for those of you who don't know this, Alicia has just released a new book entitled Gardening with Your Head in the Clouds, a weather primer for gardeners. And I'm a gardener, so I'm really interested in this. Please tell us more about the book and how our listeners can obtain a copy.
I'm happy to do that. So in answer to your first question, I am one of the probably fewer meteorologists in the world who didn't always know that this is what I wanted to do. I always liked the sciences. I actually thought that I wanted to go into astronomy. And then when I was looking at colleges somewhere along the line, I read that there might be only like 65 professional astronomers in the whole United States. So I started looking outside into other areas of earth science. And I realized that we had a great program right here in my backyard at the University at Albany. So that's how I ended up where I am.
Yeah, you know, for astronomy, that's above many of our heads. So we decided to go into meteorology. Hey, you have the book with you. Can you show us what it looks like?
I'm happy to. So here's the book.
Oh, that's a nice cover. Yeah.
Thanks. Actually, I took the picture. That's my favorite daisies that are in my front yard. So it's called Gardening with Your Head in the Clouds. I do a lot of seminars each year, and a good portion of those are I'm asked by gardening clubs and gardening groups and cooperative extensions to come and talk about weather and climate and all kinds of issues that relate to gardeners. And it's always been a dream of mine to write a book. And my colleague said, you should really write a book. There isn't anything out there like this. And sure enough, there wasn't. So it took me a long time. I did it in my spare time, but it took a couple of years, and I'm so excited that it's in print and a reality. It's really super exciting to realize a dream like that.
Where can our viewers find something like this?
So it's on Amazon. It's also published through a local publisher up here in upstate New York, the Troy Bookmakers. So if you want to support a local business, you can go right through their website. That's Troy Bookmakers, and you'll find it there as well.
Oh, well, great holiday presents for our observers out there. Well, Alicia, I'm going to let you take it away from here. We'll be back at the end of your talk with some questions from our audience. Thanks.
All right, let me just share my screen here. Make sure I get the right window up. Okay, so we're going to start today by doing kind of a deep dive into forensic meteorology. Actually, that's kind of how we're going to finish today too. As they mentioned, if you want to put questions in the chat window, I'm really happy to answer them, and I'll definitely take them as long as there's time or after the fact. So just to give you a little bit of information about who I am, what I do, I own a company called STM Weather. Like was mentioned before, we're based in upstate New York. But actually, of all of my employees, only one, Mike, you can see on the right side there, is also in upstate New York. So we're all remote. The rest of my employees are in various parts of the Southeast United States. So we take cases from all over the country, and I'll go into more details about what kinds of cases and what we do as forensic meteorologists, since that's the topic of today's talk. But really, one of the most interesting parts of what I do is that you never know what is going to walk in the door. And I've learned a lot over the years about how meteorology relates to the law. You know, sometimes the cases specifically depend on knowing what the weather conditions are, and other times you're just providing sort of background information for other experts and witnesses to do their jobs. So it's really interesting, and there's a lot of overlap and interdisciplinary kind of work, which is really fun. As I also mentioned, we do a good amount of community involvement. And so we do seminars and school events, virtual events like this one. It's actually one of my favorite things to do is get out in the community and talk to people, because sometimes working remotely from your team can be a little bit isolating, as it turns out. So I'm always happy to do these kinds of talks. So what kinds of cases would require a meteorologist? So on the left-hand side of your screen there, you'll see a pie chart, and that just describes the kinds of legal cases that we see. Now, I mentioned I'm based in upstate New York, and attorneys like to have people who are kind of close by, particularly for smaller scale cases like personal injury, where somebody, say, slips and falls on snow or ice. So the fact that I'm within a day's drive from a lot of cities for a trial, should it ever come to that, is kind of an appealing factor. So I actually have a background in severe weather and general meteorology, but most of my cases are actually dealing with winter weather. So on the right-hand side there, you see the kinds of weather that most of my cases are made up of. The vast majority deal with either winter weather causing a motor vehicle accident or slip and falls on snow and ice. But I take cases that deal with lightning, strong winds and wind damage, severe thunderstorms, and a lot of flooding cases, as it turns out. Smaller in number, but they're a lot bigger in scope, because usually there's a great deal of property damage when there's like a high impact, very localized rainfall. So I guess this could be the last slide in my presentation, but that's not really how today is going to go. But this is just to sort of set it up and get you thinking a little bit more about how I do my job. So usually we're retained by attorneys. Sometimes it's like insurance claims rep and things like that. But most of the time we're retained by an attorney. The case is either in pre-suit or already in suit. And they have some specific questions about what the weather was doing at the time of a particular incident. So once we sort of meet with them and understand what they need to know, we set up a little research project. It's like a case study of a past weather event. And we'll go into detail about that. I always brief clients by phone before I put a report in writing, because sometimes they end up just needing the information and they take some notes and that's the end of that. If they want an official expert opinion, then I will draft up a report. And one of the things I always tell students when I give student seminars is that writing and oral communication skills are absolutely crucial to how I do my job. So it's not just doing the science well, it's also communicating, whether it's to an attorney, a judge, a jury, you name it. At the end, sometimes I do have to testify. It's not that often, honestly. Most of the cases that I work on do settle out of court. So that's really better for everybody. And if your information can help the parties reach a settlement, that's great. So when I first got into this field, which was back in 2013, I knew about forensic meteorology. And then when I was asked to speak about what I do is when I started really looking backwards just to see, where this got started. How did this field get started? And I was really kind of excited to learn that there's quite a long history of forensic meteorology within our field. So, all right, I have teenagers, and you tell teenagers never to use Wikipedia for any kind of sources, but I do actually really like the definition of forensic meteorology that they have on the Wikipedia page. So I pull that. It's meteorology applied to the process of reconstructing weather events for a certain time and location. So you get data and then you put it all together for a court case. The Certified Consulting Meteorologist designation is something that a lot of us who work in forensic meteorology hold. That certification gives you like an extra credential in court in addition to your degrees and experience and all that. So the Certified Consulting Meteorologist designation is something that's it's run by the American Meteorological Society, AMS, which is the largest professional association of meteorologists in the country. And so in order to receive the certification, you have to take a test and you have to obtain, obviously, a degree in meteorology. And you have to have a certain amount of work experience, at least 5 years in the field. So it's not just somebody who's right out of school. It actually attests that you have a good amount of experience in your field as well. There's character references. There's a strong emphasis on ethics and knowing what to do when ethical situations arise. And so the written and the oral exams both include ethics questions, which I found really helpful, because until you start looking deep into it, sometimes understanding the ethics issues that can come up, you're not always prepared. So that was really helpful. Once you have the certification, you just continue with professional development, speaking, and doing work in your field and that kind of thing. So let's go back on our dive into the records here. There's an issue of WeatherWise back from 2004, so it's 10 years old now, which was written by Sean Potter. And I really like how he sort of synthesizes forensic meteorology. The running theme of what you'll see here is that a lot of the themes are still the same, even though how we do things has kind of changed over the years. The second bullet there says that although the National Weather Service still gives forensic services to other government agencies, Weather Service employees can't testify in court unless it's the government that's involved. So that's where the private sector or private companies come into play. So those of us who have these companies, we sort of specialize in filling that need that the government doesn't do. I said that was 10 years ago. That's actually 20 years ago. Sorry about that. So Physics Today from June 2014, this one's 10 years ago, has another article written by a good colleague of mine, Elizabeth Austin and Peter Hildebrand. And they talk about, what exactly are we doing? So we're looking at the time of the event, the location of the event, what was going on in terms of weather conditions, and also what was known about the weather. Were there warnings out? Were there National Weather Service statements that would have been disseminated? Would the people have been able to receive them? And did they know what to do? Did they make the right decisions based on what information they should have had at the time? The last bullet there, I don't really too much get into modeling in my specialty, although there are people who do that as well. But the big thing is you're giving an opinion. So your role as an expert is to provide an opinion to the court. So even though you may be retained by a plaintiff's attorney or a defense attorney, we don't advocate for either side. We should be giving the same set of facts to either side, no matter who we're retained by, but you're really brought in to explain the meteorology to the court. That's your role as an expert. So this was really kind of interesting to me. Going back to 1858, this is a big legal case. It's in a lot of legal education seminars and things like that. The Lincoln Almanac trial was famous for a lot of reasons, but Abraham Lincoln at that time was representing a defendant who was on trial for murder. And they had a prosecution witness who claimed that they saw this defendant from 150 feet away by the light of the moon. So Lincoln did his own little forensic work and went into the Farmer's Almanac, which was probably the best reference at that time, to show that the moon was actually not in its full phase. And it was actually really low on the horizon at the time of this witness stating that they saw the defendant. So as a result, the defendant was acquitted of murder. So that's the first use of forensic meteorology to influence a court case. So Monthly Weather Review is one of our peer-reviewed publications that goes back even before 1900. And when I started digging around, I actually realized that there's a lot of information about how meteorology was used in court way back then. So I highlighted some words here. I obviously, don't expect you to read all of it, but I will kind of give you the synopsis here. It's just cool to look at the old print, I think. So in this case, the author had stated that he had been in court 33 times to talk about the weather and what bearing it might have had on the case at issue. And he also noted that many cases are settled out of court based on these records that he supplied. So this is back in 1900, and we're still doing the same thing in 2024. That is our role, and that is exactly what we're doing. 1922. This one was a cool one. Again, I love just looking at the old journals. It's just really cool. So there were several case examples in this particular article. And as it turned out, when I started reading them, they're sort of old-fashioned, but they actually have sort of contemporary counterparts. So if you look down the list there, you see an automobile collided with a milk wagon. And the question was whether there was light to be able to see. I've had cases where I was asked about twilight and how long it lasted. A woman was arrested for selling spoiled goose meat. Well, extreme heat and cold definitely still come up in my practice today. So that's for sure. Doesn't usually involve goose meat, but it's other issues at hand. Another one. Okay, so there was a railroad shipment full of barrels that burst in the cold. I have pipe burst cases that routinely come in maybe on the order of every year or two, and I just dealt with one last week. So that is still an issue that results in litigation. Freezing of water in confined areas. A man running from a dog slipped on a sidewalk. Well, there's probably other issues related to the dog bite or whatever, but they wanted to know if rain was responsible. So there's the slip and falls on snow and ice that I deal with. And lightning. In this case, they needed to know whether this lightning strike was deemed something an act of God or related to a science issue like a thunderstorm. And I brought this one up because a lot of times the question is really about how the insurance policy is written. And it's not always written by scientists. So sometimes the definitions of what things are scientifically doesn't really overlap what the policy says. So you have to figure out what actually happened and then interpret it in light of what this policy wording says. And so you're kind of explaining the science, but this is what your policy says happened too. So there's, a way of explaining it that explains that there's like different definitions based on how they have this thing written. So that comes up a lot. 1925, I picked this article because this one was a dredging case. So there had been dredging on this waterway. And there was a question, some lawsuit related to that. But this one I picked because it was on a waterway and, you're dealing with other experts like hydrologists. Sometimes I deal with architects or engineers. And believe it or not, we don't all speak the same scientific language. So when you're dealing with somebody who deals with runoff and water and where it goes once it hits the ground, your words and numbers may mean something very different when you're talking to other experts, but those are fun cases where you're collaborating and discussing things with other disciplines. So obviously aviation is another area where there's a lot of weather-related litigation that can come up. This was a big one back in 1985. There was a flight that was going from Fort Lauderdale to Dallas, and the plane crashed just shy of the runway on landing. The meteorologists were brought in, and this was one of the first cases, if not the first case, where simulated graphics were used to overlay sort of what was going on in the cockpit, what was going on with air traffic control, where the plane was, what the weather was doing with the radar. And so these graphics were used at trial. Again, I think it was the first time, if not one of the first times. So what ended up being diagnosed was that this plane basically flew into a microburst just shy of the runway. And I'll show you in a second here. We're going to deviate a little bit from legal stuff. When you have a microburst, which is a downward moving column of air that hits the ground and spreads out like a pancake in a thunderstorm, it's in that little yellow inset box there. Imagine a plane flying through that, and that's sort of the diagram on the right-hand side. And so the plane is trying to land, and the first thing it encounters is a strong headwind, right? Well, the headwind's going to lift the aircraft. So what's the pilot going to do is drop the nose. And then as you cross through on the other side, all of a sudden you have a tailwind, which now decreases your lift. and the plane essentially nosedives onto the ground at that point. There's not enough altitude to correct for the errors at that point when you're that close to the runway. Despite the tragedy, there were some really good outcomes that came from this case, which include crew training, an FAA mandated warning system for microbursts. And so you'll see, you know, ground stops when these kinds of things are anywhere near airports nowadays. Sometimes I'm asked if I get criminal cases. I can count on one hand in 11 years the number of criminal cases I've had. So yes, but not very often. That may not be the case for other experts, I don't know, but at least in my own practice, I don't get too many. They're interesting because you don't usually know a lot of details about the case. They bring you in specifically with questions about the weather. How long was twilight? What was the melting conditions like in this specific spot where this photo was taken? You know, things like that. But you don't know a lot of other details. This case was a criminal case that was actually a book, and it's a Netflix series. I think it's called The Staircase. I haven't watched it. I probably should. But this was a murder trial as well. And a certified consulting meteorologist was brought in to talk about the case and the weather and what happened. So this was back in 2001. And the defendant, the husband, was on trial for murder. And he said that he found his wife. She had fallen down the stairs and hit her head, and he found her shortly before 3 a.m. He claimed his alibi was that he had been out at the pool wearing shorts and a t-shirt for the last 3 hours. So there was a lot of other things that played into this case besides the meteorology, but Bill Haggard, the CCM who worked on this case, noted that there was no weather station nearby, which is common. It's very typical for our cases, right? You don't typically have them happen where a unit is located. And so he made a map and did it by hand and interpolated and drew isotherms or temperature lines along the map to determine what the temperatures were between weather stations where this incident happened. And he determined that the temperature was falling through the 50s at the time that this man, the defendant, said that he was sitting outside by the pool in shorts and a t-shirt. So that didn't help the defendant's cause. And like I said, I'm sure this wasn't the only factor that played into the case, but weather did play a role, and he was ultimately found guilty. So you can look that up later. It's a Netflix series, so it should still be on Netflix. But I haven't watched it, so I don't know. So that's a little bit about the history of the field. It's I always love talking about it because I'm just really interested about how people used to do what I do today. You can always learn from the past, so I kind of get into that kind of stuff. But now I'm going to talk a little bit about how we do what we do today in my practice these days. So that's kind of the next section of what we're going into here. The first thing that I always do, or that my team always does when we are getting into a case, is to try and put together all of the data that we can. There's a lot of different data sources. I'll cover some of them here today, and they all have pluses and minuses. The most common one that we go to first are those usually airport observing sites that are part of the Automated Surface Observing System, or ASOS. They're federally maintained for the most part. You know, you can get hourly, you can get 5-minute, 1-minute data, you can get a lot of different weather parameters, and it's really well documented, and you know how they're maintained is kept up as well. So these are great. They're usually near population centers. So if you have an event that happens in a remote area, they may or may not be helpful. The Cooperative Observer Network is another one that we like to use. Over 8,000 volunteers, and it's been around since the 1890s. So a long-standing network. And some of these stations are great when we're going way back into the weather record, because some of these stations, although the observers have changed, of course, they've been around since the 1900s, like early 1900s. So if you're looking to do a long-term weather study, these cooperative observer sites are really helpful in those cases. The downside is that you only get once daily observations. Usually it's precipitation, snowfall, snow depth, and generally, but not always, high and low temperature for the day. You guys, we use and rely on your data to do our job every day. And I can't understate that. So your once daily observations are really helpful in filling in holes where there aren't ASOS units, for example. Obviously, we don't have temperature traces, we don't have hourlies, but your precipitation and snowfall and snow depth measurements really help. And I'll talk about that later on, about how the CoCoRaHS network helps us to do our job. So in New York State, we have a statewide network of weather stations. It's called the New York State Mesonet. A lot of other states have their own mesonets. It varies on how they're put together. Sometimes it's just an aggregation of different weather sensors from different agencies. Sometimes, like in New York State, it's a unified network where it's all standardized and maintained and run by one group. It just depends. So they're helpful, but they're not always the same, which can sometimes be a drawback as well. There's not always great information about the sensors and how they're cited and all of that, which can become important down the road in a trial. So in New York State, we do have a certification, which also helps. And I'll talk about that in a little bit as well. Other data, depending on the case, we pretty much always pull radar to determine where precipitation was occurring. When sometimes we're doing severe weather analysis, if there was hail or wind damage or something like that. For precipitation, the return period, or how common or uncommon these types of rainfall events are, can become really important. So we're referring to NOAA Atlas 14 for those kinds of statistics. Like I mentioned, a lot of litigation nowadays, there are questions about decisions that were made and who did what, when, and what information did they or should they have had. So National Weather Service chronology of warnings and any other statements that are relevant is always something that we do. We don't always use lightning. You know, there's some other random little data sources, buoys and things like that, that, you know, you use for certain cases, but not so much all the time. So lightning would be kind of one of those. So back to the history books now. 1971, the Bulletin of the American Meteorological Society, or AMS, had an article, and it is 100% true. It is a rare case in which the site involved in the litigation happens to be in the immediate area of a weather station. I have had maybe I would say less than 5 cases over the years where somebody slipped and fell at an airport. It happens, it's just not that common. And if it does happen, it's usually not where the ASOS sensor is located, because that can be miles away, even on one airport site. So this, unfortunately, is still the problem. And that's part of why we're called in as experts today, is to synthesize everything together and come to a best opinion about what happened where there aren't observations. So all of the stuff that we use to put together an opinion has positives and negatives. And this can all become important down the road if something goes to court. Because if you are an expert in court and you're credentialed and you have your degrees and all of the things that say that you can talk about this topic in court, but you rely on data that's bad, that's not quality controlled, that's not commonly used in your field, it's some off the map weather site that you don't know anything about, your whole opinion can be tossed out. Okay, so you have to make sure that you're using data that has its own credentials, because you're explaining to the judge and the jury why you relied on this data to formulate your opinion. You know, you can't just take a random weather site that happened to be, you know, that this guy had at his house or whatever, and he said oh, you can use this. That wouldn't help your arguments and wouldn't help your opinion hold up in court. So the things that we're always considering are data availability. Some networks more than others, there's a lot of missing data. And obviously you guys are a volunteer network. So there are times, I mean, my husband is a CoCoRaHS observer here at our house. And, you know, if we're away, there are multi-day observations. I live in New York. I don't like going outside to take the obs in the wintertime. So he's our CoCoRaHS observer, but most days he's out there taking the ob at the right time of day and all of that. But data availability can be an issue. Is it representative? Like I mentioned, I'm in upstate New York. So we have the Adirondack Mountains. We have the Catskill Mountains. I live in the juncture of the Hudson and Mohawk River valleys. The elevation changes over short distances can sometimes be really impactful with the weather. I'm about 1.5 miles from the cooperative observer at the Troy Lock and Dam, which is right down on the Hudson River. That's about an 11 feet elevation, and so not far above sea level. I'm about 440 feet above sea level. And there have been times when it has been snowing at my house and accumulating, and I drive down to the river and there's nothing on the ground. So there are cases when you can have sites that are really close by in distance that are not representative because of factors like geography. Again, like documentation is so important. Whether the data is quality controlled and how that is done is also important. Sometimes networks like Lightning are proprietary and there's a cost incurred just to get the data. So obviously we're not going to use Lightning data if we don't need it for a particular case. But we might have to pay for data sometimes. And if a client's on a really tight budget, there's some trade-offs there. Is it necessary? Like I mentioned, do we need Lightning for a slip and fall? Not usually. And then is it certifiable? So NOAA and the National Center for Environmental Information offers a certification for any data that they archive. So that includes cooperative observers, you guys, CoCoRaHS data is archived at NCEI. And so all of your data is certifiable. And if it's certified by NOAA, it pretty much gets admitted into court with no questions asked. Nobody's going to argue about certified weather records, except one time in trial. It was one of my first trials. So that's another story for another day, but they shouldn't. It should be just accepted. Same thing for the New York State Mesonet. That's why another reason why we like that data network is because they offer a certification that attests to the standards and quality control and all of that. So there's a lot of considerations with finding the right data. I've spent a lot of time on this slide, but it is so foundational to formulating an opinion that I don't really think I can underestimate it enough. I mean, it really is important to get a good data set. So from there, we've talked with the attorney. It's always interesting because sometimes what the attorney thinks they need to know isn't always what they actually need to know. And you can kind of help them understand, like, okay, yes, we can find out whether there was a storm in progress here, but you might also need to know what the sun angle is, because if there was melting and it was inhibited by a shadow from a building or something, then there could have been ice here, and different areas maybe there wasn't. So sometimes you have to help the attorney sort of think about the questions from a science perspective. Sometimes they know exactly what they need. You take all your data, there's my little red box, and you put it all together, and here's where the communication comes in. You put together a chronology of events. It has to be clear. Attorneys like words and not pictures, so I do a lot of talking in words, which is unnatural to me as a scientist. I always, wrote as a scientist by getting your figures or images together first, and then you write your draft from that. But writing for attorneys is not that way. And then, even briefing them, like you have to get your bullet points together, and they may only have a couple minutes and they just want to know what the highlights are. Some attorneys want to spend half an hour and cover every single nuance of the case. So you have to kind of know how to communicate, just depending on the personality of your attorney, and get across the points that you feel are really important for them to know. And it's different every time. So that's kind of, again, it's a fun thing about what I do, but sometimes it can be frustrating when you and your attorney kind of don't see eye to eye about what's important in this particular chronology. So since this is a CoCoRaHS webinar, I really wanted to spend some time today and talk about why this network in particular is so helpful to us. The fact that you guys are everywhere, I say you guys, I mean, like I said, my husband's one too, so I should say we are everywhere is really very helpful. The fact that you have training and that your reports are quality controlled and they're archived at NOAA, like this is all fantastic. And it makes it a very reliable, dependable network to use. So I went back, this is about a year or so ago, maybe a little bit more, but I don't think the numbers have really changed that much. Almost all of our cases, like it is a very rare case that we don't pull some CoCoRaHS data. And those would be the ones where like the ASOS is like on site, almost on site at an incident. You might not need a CoCoRaHS for that case. So most of the time, without question, we're grabbing CoCoRaHS data. Generally, we use anywhere from 1 to 4 sites per case, and it just depends on how close they are and what the terrain looks like and whether the nearby ones are the most representative, that kind of thing. There's about a quarter of the cases where the comments that are in the observations are very crucial to forming an opinion. So I'll talk about that. This is what the data looks like when I get it from NOAA, which is, of course, how we get it. It's how it comes certified. You can get it from the CoCoRaHS website as well, but the certified copies look like this, and they come from NOAA. So this observer here, you can see, maybe you can't see, I don't know if you can, but I circled it. If we're looking at December 2nd of this particular year, we can see how much rain fell or how much snow fell. Okay, so we know that there was 0.77 of an inch of rain. I could use my mouse here. There we go. 0.77 of an inch of rain. Of that, or of liquid precipitation, and of that, half an inch of snow fell also. But notice that the observation times in the top right, my boxes are offset here, they're unknown. So even though on the CoCoRaHS website, where there's no certification option, you have the entries and they're there, the official NOAA record doesn't show that the observation was taken at a specific time. So that's a little bit frustrating because this is the official record that we're basing our opinion on. No information about timing of the precipitation, no information about type of precipitation, and all of that. But you and I well know that there's a lot more information in a CoCoRaHS observation, right? So often we do go to the CoCoRaHS website. Now we're into unofficial, so we can't formulate our opinion based entirely on specific information in here because it's not certified from NOAA and all of that, but we can use this to support our opinion. So in this case, where the 0.77 of an inch of rain happened or liquid content happened, the observer noted extensive comments. There was heavy snow during certain times, which turned to sleet, turned to freezing rain, and then it ended at 4:30 when the temperature rose above freezing. It talks about ice accretion, wind and weather conditions at the time of the observation. So this is vastly more information than is in the official observation. And we can use this to support what we're seeing in the other official data, like radar, for example. So these comments are very helpful in supporting what we might see in radar data. It just gives a little bit more beef to our opinion when somebody else notices this as well and thinks to write it down. So show me an example, please. I'd love to. Okay, so I do a lot of slip and falls on snow and ice. And so I'll talk about one of those today. It happened at this little train station in Eastern Massachusetts. I know we have an observer from Massachusetts on the call today, so thank you. And you can see there's some interesting things. This was taken not long after the individual fell. There's bare pavement exposed here. There's what clearly looks like some oldish, maybe snow or ice, but we don't know how old. There's some areas where it's melted completely. There's some areas where it's not. There's an area like a sidewalk around the front door to that station that looks like it probably was treated with something because there's snow and ice right next to it on the pavement that isn't on the sidewalk. So there's lots and lots of issues. There's a crosswalk there. You can see the crosswalk goes right into the kind of snow and icy area. There's snowbanks. There's a lot of things going on here. So this was an area of public transportation. Like I mentioned, it was a train station. It had really kind of mixed things going on in the picture. We don't always have pictures, but in this case, it was actually really nice that we had a photo taken right at the time of the incident. So the chronology I'll go over here was, fairly straightforward in terms of the weather conditions. There was a storm off the coast. There was a wintry mix of precipitation that had happened about 3 or 4 days earlier, and then a freeze, and then a thaw. And at the time of the incident, the temperatures were in the 30s, upper 30s, so above freezing, and light rain was falling. And based on the nearby observations, there was about 3 inches of snow depth remaining on untreated, undisturbed surfaces. There were questions, again, legal questions, not so much related to the meteorology, but about who cleared what when and what should have been done based on the law and the code about when those areas should have been cleared after the original storm 3 to 4 days prior. So again, nothing that I have anything to do with, but I'm just supplying the chronology for the attorneys to kind of sort it out. The comments from the nearby observers were great, right? Plaster-like mix of freezing rain, sleet, and snow. Solid mess. Mixed precipitation all day. Plenty of sleet. Driveways and walkways are a mess. Existing snowpack has been compressed due to rain and sleet. So we can see this in the observations. Like I can see that the snow depth is decreasing each day, and I can see that there's rain, and I can say to myself, okay, so, you know, there's above freezing temperatures and rain, the snow is going to compact, you know, whatever. But again, now I have somebody else who's actually seeing it in real time and observing it. So the fact that I'm seeing it in hindsight as a scientist is corroborated by what observers were seeing in real time. So that's really helpful. After the storm, observers noted things like that the ice was even worse the next day. It would rain overnight, temperatures had been above freezing. This was the observation taken the morning after the fall, and noted that there was a little bit of extra snow on top of the frozen surfaces, and when that snowfall had occurred. So again, these are not things that can be used to foundationally support my opinion, but it can definitely help support what I see in the weather record. And I can say, well, you know, this was observed by observers on the ground. So the whole opinion here ended up being basically that any white snow that was there was from the storm 3 or 4 days prior. Any wet or black areas had probably been treated or cleared by someone at some point afterwards. And that is the extent of what I say about what was done to those surfaces. I'm just supplying the weather chronology. So that's how they all fit together. I have no idea how the case ended up settling. Most of the time, unless it goes to trial, attorneys don't let the experts know how things end up. So it's like a bunch of, you know, you get to the last page of a book and then you close the book and don't finish it. That's how most of my work is, which is a little bit like a bug in my ear, but it's okay. You know, it's just part of the job. So it's nice to hear how things turn out, but most of the time we don't. Other examples of where the comments are really helpful. Again, it's really in support of what's in the official weather record. Where freezing is occurring. So this observer on the top left noted that it was happening on deck surfaces, but not on the asphalt. That's helpful. Treacherous walking, also helpful, you know. Intensity of snow. Okay, there was 2 bursts of snow during the day. It was very light and fluffy. Those kinds of characterizations are things that you can kind of infer from the official record, but seeing the words often helps kind of piece together that story very clearly for an attorney. Where the snow depth is melting and where it is not. There's just a few little bits left in the shadowed spots. That's really helpful to know. The overnight low is above freezing, but there's still some ice in certain areas. Okay, that's good because there are times when we have those 2-meter observations of temperature and they are like right near freezing and we don't have ground temperature measurements that are readily available. So we're just inferring from what the air temperatures were doing and for how long they had been below freezing before, whether the ground might have been frozen. So when observers note that, yeah, there was ice in some areas, even though the air temperature was above at my house, that's helpful. Like I said, it verifies what we kind of think is probably going on based on the other data. Light rain just before midnight contributes to slushy nature of the snow. This is all, like I said, characterization and description that helps add context for when you write a report for attorney. Damage also, I mean, we have local storm reports from the National Weather Service, but when there are reports inside the comments, that's something we can also note. So anyway, lots and lots and lots of helpful data and information in the comments. And so as just a matter of course, we always go back and pull the data from NOAA, but then go directly to CoCoRaHS and pull out the comments as well. One thing I would say is, like, if you guys are taking your measurements, you know, those comments are helpful. I joke about this with my husband because he is our CoCoRaHS observer, and you know, I like, you really should put comments in, like, you know, put some comments in. It's very rare that I actually have to use my own house as a supporting data point, but sometimes you don't think to put the comments in, and it does help after the fact. So we appreciate that. Also, the whole, writing zeros versus leaving blanks can be very helpful, because even though we don't think there was any snow on those days where it was blank for, 2.5 weeks before a storm, having the zeros in there really corroborates that. And the way NOAA pulls the record, we see blanks as blanks and zeros as zeros. So we don't really have a way of knowing necessarily if it's blank, whether it was blank or whether it was zero. So the comments in the CoCoRaHS are highly appreciated, and all of the reasons that you see here in the list are, like I said, I could go on and on and on about it. It really just helps us do our job better. So I think I mentioned, like I said, leaving the blanks blank versus zeros. Zeros are definitely helpful. Getting that time of day, time of observation in is also helpful. There are sometimes questions where an incident happens right around observation time. And so it always says unknown in the NOAA record that we pull. But if we go back to the CoCoRaHS site and we see that you took your observation at 8 a.m. versus somebody else nearby who took it at 6 a.m., that can sometimes really help pin down a temperature chronology if temperatures were like dropping below freezing right around 7 a.m., for example. So, those things are important. That's if you record temperatures. I know not all of you guys do. Same thing with precipitation though, too. Like if there's an end time question and it's right around observation time, that can be really helpful knowing exactly when that observation was taken. And of course, the multi-day totals. Again, sometimes that doesn't always pull into the NOAA PDF, which is the certified one that we have to supply to the attorneys. So it should have a little A after it if it's a multi-day, but sometimes it doesn't. And I don't think that's a situation from CoCoRaHS. I don't know if it's just how the data gets pulled in, but there are situations where that does come up as a question as well. And then sometimes we can't always rely on a particular site because we think it's a multi-day, but it may not be. So just being explicit about your observations is so helpful. So we've been around the block today. I probably talked a little faster than I expected to because I love talking about this stuff, but hopefully that'll leave us plenty of time for questions. So we talked about the history of forensic meteorology and all of the, the long history of the field and how data analysis used to be done, how it is done today, which I think is where we mostly focused on. We talked about the importance of good data. Like I said, I cannot underestimate this. It's a scary thing to have your data questioned in court. I've had that happen before. I mentioned that case where it was one of my first trials, and for some reason, I later learned this shouldn't have happened, that the judge wouldn't allow certain certified weather data to be admitted. So I couldn't use the radar, and I couldn't use, there was something else. I had one ASOS site that I was allowed to opine about. Fortunately, it was enough to tell the story, and the case settled appropriately as to how it should have based on the weather chronology, but it was kind of a scary moment. So good data is absolutely crucial. The idea here is that we're actually just helping the process settle out of court. So you're giving information to the courts and both sides to help them settle their case. So, and thank you. I gotta say thank you to CoCoRaHS observers. Like I mentioned, we have a gauge here at our house, but it is not me, I must freely admit. But we cannot do our job without the dense network that you guys help us with. So I think we have lots of time for questions. I'm going to wrap up here. I put the picture of the book in case you guys want to take a look. It is, if you scan that QR code here that appears on your screen, you can get to my website. I'll show you in a second. Because, like I mentioned, it's available on Amazon. It's also available at the local publisher. So I don't know, I think you can see it. This is my website. If you just scroll down here just a little bit, you'll see the book, and it's at Amazon or Troy Bookmaker Books. So if you want to support local, you can always click on the Troy Bookmaker link and buy it that way. I kind of like to do that just because I'm a small business myself. But anyway, thank you so much for your time. I hope this has been interesting for you, as fun as it has been for me. And Henry, I think we have time for questions.
Yeah, we sure do. And thank you so much for this great presentation today. I think everybody will agree that we got a lot out of it. And so I was With Thanksgiving coming up now, I'm going to be careful if I look for any goose meat out there. So that's my lesson learned. But okay, we got questions, folks. If you want to go ahead and type them in, be sure to include the state and your first name, where you're writing from, and we'll try to get as many as we can here in the next 15 minutes. So Michael wants to know if there is a historical lightning data source. Is there something that goes back? I know there's lifetime stuff, but where do you go for historical lightning?
Yeah, that's a great question. So it actually originated at the University at Albany, where I went to school prior to my time. That's where the original National Lightning Detection Network, or NLDN, was developed. It used to be freely accessible, but had since, I think even by the time I got to school, been privatized. So now I think it's Wasula is the company who owns and operates the network and the data archive. So anytime we need lightning data, it's an easy order. It's not that expensive, but it's just not one of those things we get all the time because we got to pay for it. So unless you can justify needing it, there's no reason to get it.
Okay, thanks. One of our observers wants to know if you could put the QR code back up on the screen. They didn't get a chance
I'm
to.
sorry about that. I realize that now. Okay, hang
Yep.
on one second here. Let me how's that? That work?
Let's see. Yep, that looks good. Great.
Great.
Hey, we've got so a lot of comments in here, but any more questions coming up for Alicia? So here's one. Ed wants to know, again, you mentioned earlier that you're a CCM, but he wanted to know, is it necessary for what you do? How important is that CCM seal?
So I would say this is one area of meteorology where it is quite important. The seal is not accredited by like an independent agency, but it's a very rigorous certification that is monitored by the AMS, which is a known national entity. So, you know, it's something that in court can become very important. I have advanced degrees. Not everybody who does what I do does have an advanced degree. I mean, I've been asked about that, and you know, it definitely helped me on my path, and I feel like it helped me become a better forensic meteorologist. But there are people who have way different experiences, come from the broadcast field or come from different areas of the private sector, and maybe never went to grad school. And so that cases, especially the CCM, can really help sort of attest to the credentials and the ethics. I mean, you know, if we're going to sit up in court under oath, ethics are of ultimate importance. So that's really important as well.
Great, thanks. Okay, any more we got coming across here? Here we go. Ray from Missouri wants to know, how long does it take to work an entire case from start to finish?
That's a really good question. So I would say that slip and fall personal injury cases are probably the shortest, on the order of maybe like 10 to 12 hours by the time you talk to the attorney, get the data, do the research, brief the attorney, write the report. So not up through trial testimony, assuming that it settles after your report. Those are probably the shortest because you're usually just looking at like one storm at one time in one location. Anytime you've got like flooding, for example, or more complex weather that might require radar analysis, so like severe storms or hail or something like that, the time kind of exponentially goes up from there. So you could spend as much as like 20, or I don't know, I've had cases where I spend even like 30 hours between me and my team splitting up some of the work on a particular case. You know, you're looking at weather service warnings, and sometimes those chronologies for flooding they're rapidly unfolding events. So just putting together what happened at the weather service side can take a good amount of time. And then what happened with the weather data and the chronology of weather events itself takes time. And obviously writing a report that's more involved like that takes time. In those cases, we usually put together a PowerPoint to brief the client because there's a lot of complex issues. So yeah, I would say anywhere from like 10 to 30, depending on the type of weather event.
Okay, great. Here's one. It's an interesting one for Barbara. She said, Barbara wants to know, are there any cases where both sides bring a meteorologist? Can the data be conflicting between testifying meteorologists? So that's a good question.
That is an excellent question. The answer is absolutely yes. Sometimes there's cases where there's questions about which data an expert used to form their opinion. So anytime there's another expert report that's disclosed, I should mention it's a pretty small field, so a lot of times it's somebody I know as a colleague on the other side. In theory, you think, oh, you're looking all at the same data, everybody should come to the same conclusions. But that's not really the case. So barring the situations where somebody relied on data that I wouldn't have for X, Y, and Z reasons, or that kind of thing where you're kind of debating what is the foundation of the opinion, there are still situations where two very credentialed experts can look at the same data and come to maybe not totally different, but different enough for court opinions about what happened as far as timing of when the air temperature dropped below freezing, or I'll give you an example. Like if you have a case where there's snow, which ends, and then there's winds afterwards that are just blowing snow, you can have sensors, automated sensors that are picking that up as new snowfall or not. And sometimes you believe for various reasons based on everything you're looking at that like, okay, there wasn't actually any additional accumulating snow. It was probably just this blowing stuff because the winds were X, Y, or Z. But there's these gray areas where you can actually come to a slightly different conclusion about the precise chronology of events. And it's just the nature of looking at imperfect data that's not improperly spaced. It's just unideally spaced around an incident. So yeah, that absolutely happens. And a lot of times it's very collegial. But you do sometimes have to rebut another expert's opinion if you disagree with it.
Here's one. Patricia was wondering if you've ever had to challenge folks like FEMA, like with the Hurricane Helene disaster. Is there any do you go up against any government organizations like that?
That's a good question. I've had a handful of cases which involve various federal government agencies, but usually it's like the Army Corps of Engineers and maybe, related to their operations at a dam or something like that. So a flooding type of case where really the role of the meteorologist is just to tell everybody else how much rain fell over what time period. There's a lot of cases that are on a smaller scale where local municipalities are being sued. Again, it's a lot of the flooding ones for some reason, and it can sometimes have to do with zoning. It can have to do with maintenance. I've seen cases where there's like culverts which overflow, but they hadn't been touched in like 30 years. And so, the town hadn't been in to clear them out or whatever they were supposed to do for maintenance. And, again, these are issues that aren't meteorological, but when you get 5 inches of rain from a thunderstorm that sat over an area, then it becomes a lawsuit. So yes, but I would say most often it's like small municipalities versus like the federal government.
And speaking of the federal government or state governments, has there been any kind of administrations you've had to deal with on either level that have kind of impacted your ability to access active weather and climate information? One of our observers.
You guys are asking amazing questions. So yes, 100%. It doesn't necessarily matter the administration, but if there's a government shutdown, we don't have access to, they shut down the NOAA websites. So, in theory, they could just run even though nobody's there, but they don't. They shut everything down. There are some backdoor ways. Iowa Environmental Mesonet is one where you can get NOAA data. It's not official, it can't be certified, but they're pulling from, the same data sets. So we can use it, but everything takes longer. It's not in the usual formats. It can't be certified. So it just like really complicates matters. And then I would say this is kind of a big thing recently was that the national centers where the data is archived, excuse me, it's in Asheville, North Carolina. So after Helene, these poor folks were dealing with their own mess and disaster, and the National Center was shut down for several weeks, and we couldn't get data. And, like I said, there was nothing that could be done about it, and there is not a separate secondary backup site either. Fortunately, they were able to retrieve or protect everything that is paper, so all the really old stuff. And they eventually got the websites back up and running. But, anytime where there's a government shutdown or the websites from the government are not accessible for any reason, that's what really hinders our work.
Okay, Andre wants to know, other than Lightning, which you just answered, is there a fee to access certified data? So do a lot of folks other than Lightning, Wasula or whatever
So,
group?
yeah, no, that's a good question too. We always this is taxpayer funded, right? So you or I or anybody can go to NOAA and the National Center and download any weather record that they maintain in their archive for free. And so we always do our research based on the uncertified copies because they charge per page for certification. It's not an electronic certification at NOAA. I'm told that their counsel is like looking into it, but this is probably going to be beyond the scope of my career by the time they do electronic certification. So it involves them actually like printing out the records, putting the certification page on the top and binding it all with a blue ribbon seal. So this incurs a fee plus the shipping, and it's pretty expensive. So usually, unless there's like a motion being filed or something like that, we can order the records at that point. But the opinion is usually based on the free stuff that we download. It's the same data, just doesn't come in the blue ribbon package.
Yeah, it's funny. I remember working at it was NCDC at the time, and I remember going in and watching a gentleman that would put the seal on and put the ribbons on. It was kind of fun to see how they certified the data back then. So that was one of his main jobs. Okay, we're going to take two more questions since we're at the top of the hour, and we'll answer the other ones offline here if possible. Not if possible, but Alicia will follow up with you on those. Okay, real quickly, Gerald from Florida, is there a type of case that you consider the most difficult? So, oh, that's a good one.
Oh, yeah, that is a really good question. I wouldn't say it's a type of case. I would say any case where the meteorology and the chronology of events is complex or where there's a lot of gray area. Like I mentioned, the end of a storm legally is like when the precipitation ends, but sometimes there's trace precipitation that continues for a long time, or sometimes there's exacerbating factors like winds. And so whenever you have a case, which is why we're brought in as, right, this is why we do our job, is to help explain this complex stuff. But those are the kinds of cases that can sometimes keep you up at night because it's complex as far as discovering what happened and putting together chronology and then conveying it efficiently can be challenging as well. So those are the ones that, you really have to like think about the words in your reports and all of that. So it's not a specific weather type. It's more just like, any particular case where there's complex weather.
Okay, and our final question of the day, and this is a good one to end on. Do you have any tips for meteorologists wanting to become more involved in forensics? Brad in Iowa writes that one.
Okay, that's a good question. It's a pretty small field. It's like a little niche area of meteorology. You can find one on the AMS directory that's in your local area. I do take interns periodically, and I'm sure other people, if you're interested in just learning more about it, a lot of us just really like what we do, so we're happy to talk about it. And if you want to learn about it, I would definitely recommend reaching out to somebody in your state who does it. Also attending conferences when you can, which I know is tough sometimes financially, but if you can attend conferences and just learn what small business meteorologists are doing, if they're presenting at different conferences, that's also a great way to sort of learn how this little area of meteorology operates. It's really just it's such a small network, like I said, so it's really just a matter of getting to know people and learning from them.
Well, Alicia, we really want to thank you for taking the time out today to be part of our webinar series. We really enjoyed it, and hopefully we'll have more collaborations together with you in the future. And folks, I think the one thing that Alicia really stressed was if you can put in comments, please try that, especially if you have precip or stuff that'll be helpful to not just the forensic meteorologists, but other entities out there. It really goes a long way, especially if you have really heavy rain or heavy snow. We look at a lot of times the observations and wonder if it's legit. And so by seeing that you have a comment, yep, it did fall, and it wasn't an error, that a typo or something, that is really helpful. So, all right, well, as we close out today's program, we want to let you know that our next Weather Talk webinar will be taking place in early January. So get your calendars out, January 9th. and it's our annual special review of significant weather events from 2024. This is a favorite of many folks out there. It's presented by Greg Carbon, who is now retired from the Weather Service and living in Vermont. And so we'll have more registration information on our Weather Talk page shortly. And we really hope you can join us for that one. Before I forget, when signing off today, please take the survey that will pop up on your screen. So until we meet again, this is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now. We wish each of you a happy Thanksgiving and holiday season ahead, and stay clear of that sketchy goose meat. All right, take care.